Hello, my name is Simeon, and today we are going to talk about direct preference optimization. First, we'll go through the theory and the paper where everything started. Then we'll cover the different concepts, and finally, I'll show how to fine-tune in OpenAI platform. This is something which they recently announced like a possible thing. And at the end, I'll show some open source libraries to fine-tune with DPO, which would be interesting and to help you build your own open source and private models. So let's get started. Direct preference optimization, or DPO, is changing how we train language models to align with human preferences. In this short presentation, we will look how it works and why it matters. All started with the paper, your language model is secretly a reward model. The key insight is interesting. We don't need a separate reward model to teach language models what humans actually prefer. Before DPO, we had reinforcement learning with human feedback, or RLHF. While this works, it's complex to implement and requires multiple steps and different models. The authors of DPO paper showed us that language models themselves can understand preferences directly. What makes DPO special is that it achieves similar or better results than RLHF while being much simpler to implement. Instead of building a separate reward models and using reinforcement learning, we can train the model directly from human preferences. So let's look how DPO work in practice. This code snippet here on the presentation shows the core of DPO. It is pair responses where humans have indicated which output they really prefer. The key parts are we show the model preferred and non-preferred responses. The model learns directly from this comparison, and there is no separate reward model needed here. The evaluation is built into the process itself. Looking at the code, you can see how we can structure the input, and this is just an example. In different methods, we can have a different inputs, but just to show how it looks like. And we have preferred output here that shows what human like, and the non-preferred output showing what we want to avoid actually. This direct comparison is what makes DPO effective. So looking at this comparison, we can see the fundamental difference between RLHF and DPO approaches. The first one requires multiple steps, first creating a reward model, then using reinforcement learning to optimize the language model itself. This makes it complex and computationally intensive. On the other hand, DPO simplifies this process significantly. The beta parameter is actually here. It acts like a thermostat that controls how much the model can change from its original behavior. In the paper, they found that beta values around 0.1 and 0.5 worked well for most of the tasks. For example, the diagram on this slide shows how RLHF needs both a reward and a sample completion in a reinforcement learning loop, while DPO goes directly from preferences data to the final model using just a simple classification loss. So we can examine these experimental results comparing DPO with other methods, particularly PPO, which is proximal policy optimization. PPO is the standard reinforcement learning algorithm used in RLHF, designed to improve the model's behavior gradually while preventing too drastic changes in each training step. That's why it's a proximal. Looking at the left graph showing IMDb sentiment generation results, we see DPO, which is the yellow line, compared against PPO and other approaches. The x-axis here shows KL divergence, which measures how much the model has changed from its original behavior, while the y-axis shows reward or task performance. DPO consistently achieves higher rewards while staying closer to the original model's behavior. The right graph demonstrates summarization performance, measuring win rates against human written preferences. A key observation here is DPO stability. It maintains consistent performance across different sampling temperatures. In contrast, PPO's performance deteriorates significantly at higher temperatures because its optimization procedure, which relies on sampling during training, becomes unstable as the output distribution becomes more diverse. This instability is known limitation of reinforcement learning approaches in language models. So let's discuss the main limitation of PPO. It's a potential overfitting, which is a real concern. The models might learn to mimic the training preference too closely, and that's a problem. The binary preference structure means we can express degrees of preference. So one response must be either preferred or not. That's the structure. And the quality of the training data is crucial. We need high quality preference pairs that truly represent what we want the model to learn. But it is true for most of the fine-tuning techniques we have out there. Overall, these experimental results demonstrate that DPO achieves similar or even better performance compared to RLHF methods while maintaining simpler training dynamics. DPO has several key applications in practice. For content generation and summarization, it helps language models adapt to specific writing styles and tone preferences. This is particularly useful when you need to match a brand voice or personal writing style. In question answering systems, DPO helps refine responses to be more aligned with user needs. Customer service chatbots can learn from interaction preferences to provide consistent responses. The method is also effective for code generation and review, where it can learn from developer preferences about coding style. In education, DPO help create tools that can adjust to different teaching styles and student needs. For content moderation, it can learn to make more nuanced decisions about what content is appropriate. As we better understand DPO's capabilities, we can continue finding new use cases where its simple yet effective approach can improve how language models serve different and specific needs. In the next part, I'll show you how to fine-tune with DPO in OpenAI interface. So let's continue in OpenAI platform. First, we need to create the fine-tuning job, and you can see it is a new functionality. So when you go here, you can choose direct preference optimization option, and the base model is GPT-4o, which is the model which you currently can fine-tune on. So you can upload a new data set, training data, which should be a JSON-L file. Let me show you what I generated here quickly. This is the format. It's common in this area, so you can take a look. What I here added is the preferred output and non-preferred output. And the preferred output is something shorter and directly to the question. Here I add some synthetic data set and some kind of longer and detailed AI generated like answer. So the purpose is to align the model to give shorter and direct answers. And when we return to the core format, we can then choose this one. Of course, we'll need more samples, and this is just to show how it looks like in practice. You can add some kind of experiment suffix. And see it if you want to reproduce the job. And here, the important thing is the beta parameter. Here they have from auto to 2. 2 means that it should be generally similar to what the results from GPT-4o model look like. So we want to set a beta parameter which is lower most of the time, because we want to use what we sent like training data. So this is what it should be in this case. And batch size we can set to auto, learning rate multiplier and the other stuffs we can set to auto. And we create the fine tuning job. I already do this in this account, so here we can make very quick test. The first question is something like this. It should generate a short question, but it should be very similar to what we have originally. And here we can see the difference in the next prompt, hopefully. Yes, it's obvious. Here on the left, we can see that we have a very detailed and some kind of AI generated response, but here on the right we have a shorter and direct response, which most of the time the users prefer, but it depends of course on the context. But this is just very short example with 20 samples only. We receive this alignment. So yeah, this is just to show how it looks like. So okay, now we can go to the other methods. Here you can find this article where I explain more about the different use cases for DPO, also the mechanics and other stuffs which we discuss in this video. Let me show you other resources and tools. We have the TRL library, which can fine-tune and use DPO in open source models. We have Unsloth framework, which I personally prefer for such tasks if I want to fine-tune with DPO open source models. And we have here two notebooks which we can use. Here we have some sample code, but if we want to use some of the notebooks, we can follow the links and you'll see a complete notebook with example how to run Unsloth.AI library and to fine-tune with different models which we can of course define here. And yeah, we can produce safe and make safe inference for private models and so on. So that's the video. I hope you enjoyed. Thank you for your attention and have a nice day.